This is a question from AQA A-level Chemistry. It is a required practical question from paper 3 and it's based on RPA8. As always, I recommend that you have a go at the question first and then review the rest of the video. So let's take a look at the question. We can see all of it here, parts A and B. And if we're ready, we will now go through the answers. So in a test, aqueous iron 3 ions are reduced to aqueous iron 2 ions by iodide ions. The reaction could be used to provide electrical energy in a cell. Standard electropotential for the reduction of iron 3 into iron 2 can be measured by connecting a suitable electrode to a standard hydrogen electrode. Draw a clearly labelled diagram to show the components and reagents, including their concentrations in this Fe3, Fe2 electrode. You don't need to draw the salt bridge, you don't need to draw the standard hydrogen electrode. And there are 3 marks available. Well, the half cell is going to look like most half cells, different to standard hydrogen electrode, but almost all of the others that you will see. So I've drawn it as a beaker, I've got my liquid in there, and I have got an electrode. We need to label it. And it's important that we remember that within this half cell, where it's iron 3 and iron 2 ions, they are both aqueous. We don't have a solid component. And if we don't have a solid component to the half cell, we need to add a solid electrode. And that would be platinum. We also need to make clear that we have got Fe2 plus and Fe3 plus solutions in that beaker. We can't just say iron. We've got to recognise that there are 2 types. And then to finish off this section, we need to say that both of those solutions have a concentration of 1 mole per decimeter cube, because they are the standard solutions for any liquid in any half cell. On to part B, a salt bridge is used to complete the cell. This could be prepared using potassium nitrate solution and filter paper. State the purpose of the salt bridge, state 1 essential requirement of the soluble ionic compound used to make the salt bridge. So the purpose is to complete the circuit. Without it, we are not going to get a flow of current. The requirement is that it mustn't react itself with the ions in solution, because that would have an impact on the values that we would be measuring. That takes us to the end of this question. Thank you for listening and goodbye.